Let me get this recorded so I can upload it. All right. Now, first thing we need to do, all right, and guys, this should be something that we've seen before, all right? The Pythagorean Theorem is tied to right triangles, okay? Right triangle is a triangle that's got a 90-degree angle in it, and that is denoted down there, bottom right corner, with the little half square down there in that red corner, okay? That's the symbol that, hey, that particular angle measure is 90 degrees. You've got the Pythagorean Theorem right there at the top. A squared plus B squared equals C squared. So here's some more A's, B's, and C's. But this time we're not dealing with a quadratic. We're dealing with just a right triangle, all right? Now, the right triangle, there's basically two parts to it. Even though there's three sides, there's two parts. We've got legs. We've got legs that are denoted as sides A and B, or A or B. Guys, with the legs, it does not matter which leg is A, which leg is B. Those are interchangeable, okay? But the legs are designated as sides A and B. Doesn't matter which one's which. The big thing about the right triangle is that we understand that the longest side of the right triangle, which is opposite the right angle, is your side C. The C is the big deal. C is your longest side. It is also referred to as the hypotenuse, okay? So that is going to be your longest side. The hypotenuse is the longest side of the right triangle. It is designated side C, okay? But that is where you are going to acquire those values A, B, and C. All right? Questions? We okay with this? Again, these are things you should have seen before. We should be somewhat familiar with. This should be just a good refresh, okay? A and B are the legs. Doesn't matter which one's A, which one's B. Side C is your hypotenuse, always opposite the right angle. It is always the longest side of the right triangle, okay? All right, so here we go. First part of your assignment, okay? I believe they give you a picture. They're going to give you a triangle. They're going to label each side with some numbers, and they're going to ask you, do the lengths form a right triangle? Okay? So with something like this, we are merely going to test, we're going to test these values in the Pythagorean Theorem. Now, when you do this, the first thing I would probably go find is the largest number. What's the largest number up there? 9. That largest number is going to represent C. Okay? So if you are just testing three numbers, sometimes they call it a Pythagorean triple, okay? If you're just testing numbers to see if it qualifies as a right triangle, your largest number, your largest value is going to be your C. So we're going to put 9 over here for our C value. The other two values are going to be your A and your B, and it doesn't matter which one's which. I'm going to call 6 my A and 8 my B. You can switch those if you want. It doesn't matter. A squared plus B squared is on the same side of the equal sign, therefore it doesn't matter. So I'm going to put 6 here for A, 8 here for B. Everybody okay with this? Everybody good? Guys, once you do that, we're going to square all these numbers. What is 6 squared? 36. 8 squared? 8 squared? 64 equals 9 squared? 81. Like a big guy. $36 plus 64? 100. Is 100 equal to 81? It's not. These two things are not equal. Therefore, we would say no. Those three values do not constitute this to be a right triangle. If they do, then that needs to end up being a true statement. A squared plus B squared does indeed need to equal C squared. It does not. But that's the first thing they're going to ask you to do today is test three numbers to see if those numbers qualify as right triangle values. Biggest number is going to be your C. Your other two numbers are going to be A and B. Doesn't matter which one's which. Questions? Everybody good with that? Fantastic. All right. Does everybody have what they need here? Okay. And really from there on out, you're just going to be finding missing sides, okay? You're going to get several pictures of triangles, of right triangles. Again, they're going to denote the right angle with kind of a half box and one of those in that corner, okay? So that lets you know you're dealing with a right triangle, all right? You're going to be given two sides someplace. It could be a hypotenuse, could be a leg, could be two legs, okay? And so that's going to be part of what you've got to kind of determine as to what you're missing. Now, if we were looking at this picture here, what are we missing? Are we missing an A, B, or C? We are missing a C. Hypotenuse is always opposite the right angle. Therefore, we are missing side C. A squared plus B squared equals C squared. Again, it doesn't matter what we designate A and which one we designate B, but the 4 and the 8, those are going to be my A and my B. Okay? And then we're just going to plug in and go. 4 squared plus 8 squared equals C squared. And once we know the numbers, kind of like quadratic formula, once we know the numbers, we're just going to go insert those into our, in this case, our theorem, which is kind of like a formula. 4 squared, 16. 8 squared, 64 is equal to C squared. What is 16 to 64? 80? Now remember what we're looking for. Okay, we are looking for side C. We know what C squared is. C squared is equal to 80. Okay? How do we undo something that is squared? What is the symbol that we've been dealing with lately that will undo something that is squared? A square root, that radical symbol. Okay? So right here, in order to go from C squared to C, you will need to take a square root of both sides. The square root of C squared is C. Square root of 80. Now, is 80 a perfect square number? It's not, okay? Now, in order to continue to kind of reinforce kind of what we've worked with these non-perfect square radicals, okay? You know, could a decimal answer work here? Absolutely. Put 80 in your calculator, take the square root, it's going to spit you out some decimal. The directions might say, look, round your answer to the nearest tenth, okay? I'm going to say today, if we get a non-perfect square radical, let's go ahead and break it down so that we can reinforce that skill. Let's try to leave our answers exact. How would you break up 80? What was the largest perfect square number that goes into 80? You remember? Say again? Say it again. Well, will 64 go into 80 evenly?
Was it 16?
There we go. Good. Guys, you just work right down the list. Remember, if you don't remember, it's okay. Grab a calculator, take 80, start dividing by your perfect square number, start high, work low. You should find that it is 16. Yes. 16 and 5. 80 divided by 16 is 5. So 16 and 5. What does the square root of 16 become? So the square root of 80 becomes, in a simplified version, 4 root 5. And again, that's an exact answer. We can shove this in a calculator. We can get a decimal answer to round it off. Sure, that's easy if we need to do that. Sometimes the directions will direct us on which way to go. But that is an exact answer. And again, like I said, we're reinforcing that skill that we learned last week. Questions? So far, so good. Everybody good with where all that came from? Does everybody have what they need here? Let's do another one. What are we missing here? Are we missing a leg or a hypotenuse? Missing a leg, right? What's our hypotenuse? 7. Good. See the right angle? Everybody sees the right angle? Opposite that right angle is where we're going to find the hypotenuse. So 7 is our what value? Where's 7 going to go in that Pythagorean theorem? Going to go in there for C. So I know that 7 is going to be over there for C. This is my C value. What do you want to call 3? Do you want to call it A or B? B? So we'll say that we're missing A. Okay? So we're going to let A be A. We're going to put 3 in there for B. So we're going to go A squared plus 3 squared equals 7 squared. Three squared, 9. 7 squared, 49. Now, if we're looking for a leg, if we're looking for an A or a B, which we are in this case, guys, there's going to be a subtraction step involved, right? Need to subtract 9 from both sides. Let's get rid of those 9 so that we can isolate A squared. And 49 minus 9 is 40. So if you're looking for a leg, an A or a B, there's going to be a subtraction step involved. How do we go from A squared to A? What are we going to do to both sides? Take A square root. Take the square root of both sides. A squared, square root becomes A. Is 40 a perfect square number? No. It's not. What's the largest perfect square that goes into 40? 4 times what? 10. I like it. 4 and 10. And the square root of 4 becomes 2. So 2 root 10 is the simplified exact form of root 40. Again, if we need to shove that in a calculator, spit that out into a decimal format, we can. Round it off wherever they want us to. No big deal. Everybody good with that? I think one more. Let's do one more. Last one, right here. Again, some of these triangles are just going to be oriented different ways. Make sure you locate where your right triangle or where your right angle is in your right triangle. What are we missing? Missing a leg. So what's the hypotenuse? 12. So there's my C. This time we'll call 6 the A. We'll say we're missing B on this one. So plug in what we know. So let's go 6 squared plus B squared equals 12 squared. A little less daunting than the quadratic formula. Less stuff to keep up with, right? 6 squared, 36, plus B squared equals 12 squared. What's that, 144? What's going to be next? Subtract 36, good. If we're looking for a leg, you're going to have a subtraction step involved. 144 minus 36 is what, 108? Is 108 a perfect square? Is it on the list? It is not on the list. So, take a square root of both sides, right? You're going to need to take square root. So, if we're looking to break down 108, I'd probably say 49 is probably the first number you'd start with. That's going to be 98 twice. 108 divided by 36? 3. 36 and 3. Again, if you don't know, calculator, 108. Start dividing 108 by perfect square numbers. Start big, work small. To get to 36, gives you 3. You go, man, 36 and 3. Square root of 36 becomes 6 root 3. That is an exact answer. Guys, that's it. Pythagorean Theorem. Questions? Easy peasy, right?